In example 1, finding an actual distance, and we've probably all done this on maps. It says, what's the actual distance between Cadillac and Detroit? Well, up in the upper right-hand corner, there's the scale for the map. It says 1 centimeter to 50 miles. So 1 centimeter on the drawing would be 50 miles of actual distance. So you could use a centimeter ruler, or you could just take a little piece of paper or something that's going to be the same length as that little scale up in the corner, and every time you see one of those, that'd be 50 actual miles. So for using this from Cadillac to Detroit, the ratio they gave us was 1 centimeter to 50 miles, so that's the first ratio, and then we measure 3.5 centimeters. That's not the actual distance, of course, that's the map distance, so it goes on top. We solve this proportion, and we get that the actual distance is 175 miles. Now, for the on your own, it says, what is the actual distance between Traverse City and Marquette? And I'll let you know, it's 3 centimeters on the map. So what would it be? Finding a distance in a model, it says the liquid outer core of the Earth is 2,300 kilometers thick. A scale model of the layers of the Earth has a scale of 1 inch to 500 kilometers. How thick is the liquid outer core of the model? So we use 1 inch to 500 kilometers to start this, and they gave us the actual. So we put that on the bottom of the right-hand side, 2,300 kilometers. We solve the proportion and get 4.6 or 4.6 inches on the model. Now, it says the mantle of the Earth is 2,900 kilometers thick. How thick is the mantle of the model? So you'll use the same scale from the model, but instead of 2,300, you'll put in 2,900. So how thick would it be? Now at the top here it says a scale can be written without units when the units are the same. A scale without units is called the scale factor. So instead of writing like 1 inch to 5 inches or 1 foot to 5 feet, it's just 1 to 5 because it doesn't matter what you put as long as they're the same. 1 yard to 5 yards, 1 mile to 5 miles, as long as they're the same. We can just use a scale factor. A scale model of the Sergeant Floyd Monument is 10 inches tall. And the actual monument is 100 feet tall. So we just simplify 10 inches to 100 feet to be 1 inch equals 10 feet. What is the scale factor of the model? Well, now we want them both to be either in inches or feet. And it's much easier to turn 10 feet into inches than it is 1 inch into a foot, because it'd be 1/12 of a foot, and I don't want a fraction up there. So we turn them both into inches. 1 inch instead of 10 feet, obviously 12 inches per foot, makes that 1 inch to 120 inches. Since the units are the same, we just call it a scale factor of 1 to 120. Now, for number 3 on your own, a drawing has a scale of 1 millimeter to 20 centimeters. What's the scale factor? So put 1 millimeter on top, 20 centimeters on the bottom, turn them both into millimeters, and then take the millimeters off. So here in example 4, we're finding an actual perimeter and area. The scale drawing of a computer chip helps you to see the individual components on the chip. Find the perimeter and area of the computer chip in the scale drawing. Well, when measuring using a centimeter ruler, the scale drawing of the computer chip has a side length of 4 centimeters. So the perimeter of the computer chip in the scale drawing is 4 times 4. So 16 centimeters to go around the whole thing. And the area would be 4 centimeters times 4 centimeters, or 16 square centimeters. Find the actual perimeter and area of the computer chip. Well, 1 centimeter to 2 millimeters. And we know that the drawing distance, or the actual side length, is 4 centimeters. So what is the actual distance. You figure out the proportion, multiply by 4 using mental math, and the side length is 8 millimeters. The side length of the actual computer chip is 8 millimeters. So the actual perimeter, 8 plus 8 plus 8 plus 8, is 32 millimeters. And the actual area, 8 times 8, because you multiply side by side, length times width, 64 square millimeters. Well, here in part C it says compare the ratios drawing perimeter over actual perimeter to the scale factor and drawing area and actual area to the scale factor. Remember, it says use the fact that 1 centimeter equals 10 millimeters. Well, the scale factor, 1 centimeter to 2 millimeters, would be 10 millimeters to 2 millimeters. You take off the millimeters because we're doing scale factor. We don't need them since they're the same units, and we get a 5 to 1. So for these pictures, the scale factor is 5 to 1. So now we take the drawing perimeter over the actual perimeter, which is 16 over 32, 16 centimeters to 32 millimeters, that is, and we simplify that, and we get 5 to 1. So the perimeter ratio is the same as the scale factor. If we do the drawing area to actual area, 16 centimeters squared over 64 millimeters squared, and we simplify that, we get it down to 5 over 1 squared. Well, that tells us that the ratio of areas is equal to the square of the scale factor, and we will use this. So it says, what if, for number 4, the scale of the drawing of the computer chip was 1 centimeter to 3 millimeters? How do the answers in parts A through C change? Justify your answer.